Okay, so this answer, the midterm is seventh term, that is right. And if we are finding in terms of the A, that is between 20 and 10, right? We have removing 28, it is sixth term, right? So a seventh term from beginning. And in terms of AM, right? This is the sixth term, right? So sixth AM you are adding. Okay, our notation was in terms of A. Let me write. So this becomes A6. Okay, and the answer is 90. Perfect. Okay, let's move further. So the next concept, the next type of mean is called as the geometric mean. Right. Now, if three terms are in GP, then the midterm is called as the geometric mean of the two terms, right? For example, we'll write if say A comma B comma C are in GP, this implies, right? We can say that B is the geometric mean of the terms A and C, right? So if we have, this is the very simple condition saying that, right? If you have any two numbers A and B, for example, what does this mean? G means the B becomes is equal to root of AC, right? So in general, for any two non-negative A comma B, the geometric mean is nothing but simply root of A and B. So AC was the term, the geometric mean was root of AC, right? If we have n number of terms, right? So here we have a condition, A should be greater than 0 and B should be greater than 0. This is the must have condition, cannot be negative. We'll come to that, what happens in if one of the term or both the terms are negative. Okay. So if n number we consider, n numbers we consider, and each number is positive, what happens? Okay, so let's look at that now. So if there are n number of positive numbers, n positive numbers, say a1, a2, dot 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 up to an, right, are considered, right, then their geometric mean is equal to a1 into a2 into a3 into everything multiplied, all the terms, and you take nth root of that, so power 1 by n. Okay, and let's go to the note now. So if both a less than 0 and b is also less than 0, then their geometric mean is equal to minus root of ab. Okay, this is first point. But if a less than 0 and b greater than 0, this is, or the other condition is a greater than 0 but b is less than 0. Either this is one condition or this is the other condition. One of them is negative, right? This implies the geometric mean does not exist. There is no geometric mean. Okay. All right. Right. So that does not exist. So, but still we can apply the rule and calculate, right? It's not real, right? You will, what you get as answer is imaginary. Imaginary result. So you get an I over there if you apply the regular form, right? So root of minus a into b or root of a minus a into minus b. Either the case you get an I over there. Okay, right? This is the first point. Anyway, the equations are pretty straightforward. We can calculate if we want to find out any geometric mean. Right, let's move further to the concept where we want to insert n geometric means between two numbers, right? So this is to insert n GMs between any two numbers. All right. So let us assume that a and b are the two numbers. Let a comma b the two numbers, and let us try to insert these geometric means g1, g2 up to gn be the n number of geometric means to be inserted between them, right? So this implies, right, it has to be in the geometric progression. So a comma g1 comma g2, right, up to way all the way till gn comma b. This has to be a geometric progression for sure, right? We know that if this is the case, the b is the n plus second term, right? So this means b is equal to, according to the GP, right, it has to be the starting number a into the common ratio r raised to the power n minus 1, right? So n is nothing but, now there are totally n plus 2 terms, so this is n plus 2 minus 1, right? So using this particular equation, I can try to find out what is the value of r, right? So I'll rewrite this. Now this implies, so this means, let me write b once again. B is equal to a into r to the power n plus 1, right? So which means if you want to find r, you can find r easily. Take a to the other side, that becomes b by a. I have a power n plus 1, so take n plus 1 the root of this term, so 1 by n plus 1. The power becomes, right, 1 by n plus 1. Okay, so this gives you the common ratio, right? So now I can find all the terms, right? So what is g1? First term is a into r. What should be the second term? That is g2 is equal to a r. AR is g1 into r, so AR square, right? In the same fashion, right, I can try to find out all the terms up to the last. Okay, so, and this implies, let me write gn is equal to a r to the n. So this actually means, right, I can write g1 as A is the first term. What is R? R is equal to B by A to the power 1 divided by n. Right? So I can write 1 divided by, this is n plus 1. Okay, then the G2 can be written as G2 is equal to A into, this is B by A to the power, right? This R square, so it becomes simply 2 divided by n. So in general, you can write any Gn can be written as A into, this is B by A to the power n over n plus 1. Okay, the general equation corresponding to this. Any nth term you can calculate using this term. I just have to find out which term I am supposed to find out. Sixth term is G6, right? Eighth term is G8 and so on. Now, let us use one property. Let us try to find the meaning of this. The property is that the product of all the n geometric means of, okay, I can write between because we insert the n geometric means between the numbers gns between A and B is equal to the nth power of the single GM, that is single GM between A and B. Okay, if A and B are the two numbers, then let us try to write the equation for the AM, right? So the single GM between A and B is denoted by the capital, maybe I'll simply write, right? Say G is equal to root of AB. Now, if there are n number of GMs inserted between A and B, then they have to be, they have to follow the GP, correct? So if A, comma G1, comma G2, Gn, comma B, right, in GP, so that the G1, G2, G3 up to Gn are the GMs of the numbers A and B, right? They have to be in GP. If they are in GP, right, then the product, what is the product we are identifying? This is G1 into G2 into G3 into G4 up to Gn can be written as, so what is the first term? G1 can be written as A into R. Second number AR squared. It's not plus, it's into. Right. So this is AR square into, like that. I am multiplying AR cube up to the term, the last term, let maybe this is AR power n. Right. So you can see that A is getting multiplied n times, right? So A into A into A into A, etc. Right. So this gives you A to the n, because A into A into A n times. Multiply this with R to the power. There is first one has power 1, second one has power 2, third one has power 3 up to n. Right? It is 1 plus 2 plus 3 up to n term, because every term you multiply has a increased power compared to the previous term of R. Okay, right. Now let us try to simplify this. This is A to the n plus, now you see, it's not plus, it's multiply, a to the n into, right, I have to write r raised to the power 1 plus 2 up to n, right, sum of first n terms, right, is nothing but this is the first number, sorry, sum of first n integers is n into n plus 1 divided by 2. Already we have seen this, right? So that is what I need to write. But I know what is the value of r. Let's try to bring the term r over there. Let's replace r. So what is r? We know that r is equal to, this is b by a raised to the power 1 by n plus 1. Standard value. Let us substitute. So this means this is a to the n into, this is b by a raised to the power 1 divided by n plus 1. So this is r. I have to raise r to the power n into n plus 1 divided by 2. So basically this n plus 1 and the denominator 1 by n plus 1, right, will cancel out. Okay. Now, so this means this is equal to, I have a to the n, right? See, there is a power now n by 2 over here. Only that n by 2 is applicable for each and every term. So this is a to the n into, I have b to the power, okay, I'll write in a compact form first, then we'll expand. So this means this is b by a to the power n by 2. So I can rewrite this as a to the n into, this is b to the n by 2 divided by a to the n by 2. Right? I can rewrite this as a to the n, denominator n becomes minus n by 2 into b to the n by 2. So n minus n by 2 is n by 2. So this is a to the n by 2 into b to the n by 2. So I can write this as ab whole to the power n by 2. Correct? So the divide by 2 is in the power, means it is square root. It is second root raised to the power n. So this is square root of ab corresponding to that power half, whole thing raised to the power n. Right? Now I know that this root ab I already have, we have written somewhere. Okay, so at the beginning you can see that root ab is nothing but the actual geometric mean that exists between a and b. So I can rewrite this as g to the power n. So the statement says that, right, if you take a product of n geometric means between a and b, it has to be equal to the nth power of the geometric mean between a and b. Right? So that's the proof. Okay. Okay, let's move further. Problem based on this concept. If a is the arithmetic mean between b comma c and g1 comma g2 b, be the geometric means between b comma c, find G1 cube plus G2 cube equals to how much? So in this question, they have mentioned that the A is the arithmetic mean between B and C. So you should be able to write this. So A is equal to B plus C by 2. That is the one must have condition because A, B, C are in A is between B and C. It's given. Okay. A is between B and C. So it is a arithmetic mean. So I can rewrite this as 2A is equal to B plus C. Okay, let's hold on to this equation. Then we know that there is a GP present. What is a GP? That is B, G1, G2, comma C. This actually is in GP. This is given, right? So this means I can take the ratio, that is G1 divided by B should be equal to G2 divided by G1 should be equal to C divided by G2. Okay, so I can try to find B now. This implies, can I write B is equal to G1 square, right, divided by G2. All right. Also, I can write C, right? Also, C is equal to, if you want to find C, then that is G2 square divided by G1. All right. Now, our intention is to find the G1 cube plus G2 cube. Okay. If I add B and C, I'll try to get that. Okay. So this means, let's come back to equation number 1. So equation number 1 says, I'll call this is 2. Put 2 in 1. I'm going to get, say, 2A is equal to, this is B plus C, but B is equal to G1 square by G2 plus G2 square divided by G1. Okay. Therefore, okay, so this is equal to 2A is equal to, take a common denominator. I have denominator G1 into G2. Numerator G1 square into G1 is G1 cube plus G2 square into G2 is G2 cube, right? G2 cube. So we are getting the terms which we want. This implies G1 cube plus G2 cube should be equal to 2A G1 G2. Oh, okay, say plus. So this is G1 cube plus G2 cube. How to eliminate G1, G2 somehow? Let's see. Okay, so from this equation, I'm trying to get the product BC. That is G1, G2 can be obtained from the first and the last term. If you equate them, you get G1 into G2. What is G1 into G2? G1 into G2 is equal to BC. So simply substitute, you got the answer. So G1 cube plus G2 cube is equal to 2ABC, right? This is present in one of the solution, right? One of the options. So that's the right answer. Okay. All right. Let's try to find. Okay, next question to be solved. If one geometric mean, capital G, and two arithmetic means, that is P and Q, are inserted, are inserted between A and B, find the value of two P minus Q into 2Q minus P equals to how much? So the answer comes to be equal to G square. 2P minus Q into 2Q minus P is G square. Let's move on to the next question. Find the 5 geometric means that can be inserted between 1 by 3 and 9 and also find the product, find their product. Okay, so the question says that you have to find out the 5 geometric means that can be inserted between 1 by 3 and 9 and use the property to find their product, right, in a single step. Right. So there are 5 GMs to be inserted between these two numbers, which means the numbers in with the G1, G2, G3, all the GMs, they have to be in geometric progression, correct? So 1 by 3, G1, G2, G3, G4, G5, and 9, it's in GP. So if it is in GP, I know that I can find out the common ratio, right? Common ratio R, we have one formula, right? Now on the formula ಕಂಡುಹಿಡಿದಿವಿ just to find out the R value, right? What is R? R can be found as B by A whole raised to the power 1 by N plus 1, right? Where N is the number of geometric means you are going to insert. In this case, that number N is equal to 5. So R is equal to B by A, B is equal to 9, A is equal to 1 by 3, whole raised to the power 1 divided by N plus 1. N is 5, so this is 6, right? So 9 into 3, this is 27 to the power 1 by 6. So I can rewrite this as 3 into 3 into 3. So this is 3 cube power 1 by 6. So 3 cancels with this as 2. So this is root 3. The common ratio should be root 3. Okay, I think now you will be able to find out what is G1. Therefore, G1 is equal to AR. So 1 by 3 into root 3. So the answer is 1 by root 3. Similarly, G2 should be equal to this into R. So that is 1 by root 3 into root 3, right? Root 3 cancels. The second term is 1. Okay, proceed further. Calculate the third term. That is G3 is equal to 1 into root 3. So the next number should be root 3. Okay, then G4 is equal to root 3 into root 3. So that is equal to 3. And the fifth term, G5 is equal to, this is 3 into root 3. So that is 3 root. These are the 5 numbers that you can insert between the two given numbers 1 by 3 and 9, right? And they are in the GP. Okay, right. Let's move further. Okay, we have one important note. That is, if A comma B are the two real, positive, and unequal, they are not equal, okay, unequal numbers, and say capital A and capital G are the arithmetic mean and the geometric mean of A comma B, right? Then we have the three important points to remember. Okay, then the first point to remember, the A comma B are the roots of the equation given by x square minus 2 times capital A times x plus g square equal to 0. This is important. And the second one, so if A, B are any two numbers which are real, positive and not equal, they cannot be same, right? And we have two different terms, A and G, such that A is the arithmetic mean and capital G is the geometric mean of A and B. Then actually, if you solve the equation x square minus 2ax plus g square, you get AB as the answer. That's the first point. Point number 2 is A and B can be calculated by, right, finding out simply this is A plus or minus under root A plus G into A minus G, right? Simply solve, you get one part as A, other answer as B. A plus something, capital A plus something is small a, capital A minus this term gives you the B, right? And also one thing to note here, that is the third point, right? The arithmetic mean will be always greater than the geometric mean of the two numbers. Okay, let's solve some problem based on this concept. All right, now the sum of two numbers A and B is 100, and the ratio of arithmetic mean to the geometric mean of A and B is 5:4. So the question is, find A and B. Okay, see, they have given the sum of the two numbers, right? So sum of the two numbers means a plus b, right? So a plus b is given as 100, but we know that the relationship between the arithmetic mean and the two numbers, that is capital A, is equal to a plus b by 2, correct? Right. So a plus b is 100, so that is 100 by 2. So a is 50. Arithmetic mean we can find that. Okay. Also, they have given another relationship. The ratio of arithmetic mean, that is a, divided by g, is 5 by 4. Correct? So find g now. So g is equal to 4a by 5. Right? So this is 4 into a is 50 divided by 5. So that is geometric mean is 40. If a and g are known, can you find a and b? Yes. So we have the equation, correct? So a comma b can be found directly by applying this equation, right? I just have to find the a comma b can be found by using capital A plus or minus root of, this is a plus g into a minus g, right? Simply substitute. So what is the value of capital A? That is 50. So I have to find 50 plus or minus root of 50 plus 40 into 50 minus 40. So should be 50 plus or minus square root of 50 plus 40, 90 into 10, 900. So should perform 50 plus or minus 30. So one number will be 50 minus 30. 50 minus 30 will be the first number, that is a smaller number, A, and B should be the addition of them, 50 plus 30, 80. So you see, you got it. So A 20, B 80. So the arithmetic mean becomes 50 and the geometric mean becomes 40. So that is the required answer.